Algebra 1, Section 9.2. Before I get to the lesson, just a quick note that the answer document on 9.1, I think, had a wrong answer on number 35. The correct answer should be 18y squared plus 5y. I believe they had an 8y, which they neglected one of the terms there. So this is the correct answer as you see it. Section 9.2. If you read your textbook, you'd actually see the same example. The area is what they're attempting to calculate here. And one way that we could calculate the area, these are squares, of course, if this is a length of x and this is a length of x, assuming that the angles are right angles, then this is what we would have once upon a time in geometry called a square. And this area then individually would be x times x, or we write x squared. In fact, each one of these squares would have an area of x squared. If you look over to the right, you have a length of 1. Okay, so one of the lengths is x, the other length is 1. Area is length times width. These are rectangles, and 1 times x would just be x. Okay, so one way to express this area then would be to say that there are 1, 2, 3, 4, 5, 6 x squareds and 2 x's. So that is the area. That would be considered more work than is necessary, though. And to simplify things, what we really should do is simplify this expression for the length of the largest rectangle and this for the width of the largest rectangle. That is to say that this would be 3x plus 1. When you have one x and add another x and then another x, that's 3x plus 1 would be this whole length, and this would simply be 2x. And if I did that, then length times width, or I guess I'm doing width times length, becomes a distributive property problem. And as I multiply 2x by 3x, you multiply the 2 and the 3, that would be 6. When you multiply x by x, that's x squared. And then when you multiply here, 2x times 1 would be 2x. Okay, now I didn't time myself there. I don't know which one actually was faster, but this way is considered more efficient and really gets to the problems that we're going to do today in section 9.2. So either way, this is your answer. We like this method. 3 examples. First one says to simplify, and again, this is going to be a distributive property problem. Now, this is just a slightly more complicated than the one that we just did, but the concept is the same. I'm going to multiply negative 2g squared into the parentheses and to each one of the terms in the parentheses. Right now, a little bit of a sidebar here. When I go to multiply negative 2g squared by 3 g to the third, you must understand that these are all operations that are multiplication. Whether I put the times dot there or not, basically I left it out here and I left it out here as they did in the problem. This is a multiplication from start to finish. It's negative 2 times g squared times 3 times g to the third. Okay. Now, earlier in the year, we learned that you can multiply things in any order via the commutative properties, commutative and associative properties of multiplication. Okay, so what I'm going to do, and you can rearrange things if you want to, and sometimes you'll see the book and this software rearrange them to put them next to each other. You must realize that you can multiply negative 2 times 3. That's going to be negative 6. And then you can multiply g squared by g to the third. That's going to be g to the, right now here's an exponent property that would have come out of chapter 8, and we skipped that. I think you probably learned in a middle school class that you add the exponents. G squared times g to the third is g to the 2 plus 3, which is g to the fifth. Okay? And the main challenge here, or one of the common places that I see mistakes, is students misapplying the multiplication of the numbers versus the multiplication of the powers. Yeah, negative 2 times 3, that's multiplication, that's negative 6. But the exponents, g squared times g to the third, the exponents get added. 2 plus 3 is 5. So when I do that all together now, I don't think this is necessary work here. This was extra. When I do this, negative 2 times 3 is negative 6. G squared times g to the third is g to the fifth. And then I'm going to move on to the next multiplication. Negative 2 times 6 would be negative 12. g squared times g to the first. Again, add the exponents. That would be g to the 2 plus 1, which is g to the third. And then do the last multiplication. Negative times negative would be positive. 2 times 5 is 10. And g squared times what is essentially g to the 0. G to the 0 is 1. So really it's just g squared times 1. We get g squared. And this would be your simplified answer. Negative 6g to the fifth minus 12g to the third plus 10g squared. Notice the amount of work they show here. And I'm not against you showing work. And if you like the method that they use, they're basically showing the distributive property here in red by putting it next to each one of the terms. Don't forget to keep the negative on the -5, and then when you multiply it, negative times negative becomes positive here. They're even showing that the exponents are getting added. I like that. I don't think it's necessary, but if you want to show that work, more power to you. Just make sure you get the right answer. Next example, find the GCF. Okay, so this is going to be the first problem or exposure to factoring. One of the concepts in factoring is to find a GCF. That stands for greatest common factor. And after we factor out a GCF, later in the chapter, we'll learn what we're going to do with that even further. But for right now, we're just going to look for a GCF. And then the next example, which will be the last one for this section, will actually divide out the GCF. So look at each term. And what you're looking for is the greatest number variable exponent combination that you can divide out of all of the terms. In this case, 3 terms. So what's the greatest number variable exponent combination that you can divide out of 2x to the fourth and also 10x squared and also negative 6x? Okay, well, take them in pieces. What's the biggest number you can divide out of 2, 10, and negative 6? We're really not going to bother with a negative. So really just 2, 10, and 6. Now, if the first number were negative, we might be better to divide out a negative as well. But since this is already positive, don't worry about the negative that's over here. We're really just asking the question, what number comes out of 2, 10, and 6? And of course, that's 2. Okay, so the GCF is going to include a 2. Now think of the variable and exponents combinations. What variable exponent combination is the biggest one that comes out of x to the fourth, x squared, and x? That's going to be x. You see, if you take anything bigger than x, you're not going to be able to divide it out of the last term. If you try to divide out x squared, you can't take x squared out of negative 6x. That's too many x's. If you think x to the fourth, well, you can't take x to the fourth out of 10x squared or negative 6x. The biggest thing that you can take out is just x to the first power. So the GCF is just 2x. And the use of that can be seen in this example. Well, it will do the same thing. What's the GCF? What's the biggest number that comes out of 4, 8, and 12? That would be 4. And what's the biggest variable exponent combination that comes out of x to the third, x squared, and x? That would be x. Okay, so the GCF is 4x. And the reason that you would do that is because now you can take 4x out of this, right? When we divide 4x to the third by 4x, you'll get x squared. Now, some students have a little bit of trouble visualizing that. The best thing I think that I can tell you here is yes, division. Yes, you're dividing 4 by 4 and getting 1. You're dividing x to the third by x and getting x squared. Maybe you see it that way. But if you don't, think of it this way. Think of it in terms of distributing. What can I put here that when I multiply 4x by it would give me 4x to the third? This makes it more like one of the problems that we did previously. Well, 4x times x squared would give me 4x to the third, because 4 times 1 is 4. X times x squared is x to the third. The next one, it's going to be negative, and then 8 divided by 4 is 2. X squared divided by x to the first is x. And I'll say it the other way for this part of the example. What number variable exponent combination can I put here that when I multiply it by 4x, right, to think distributive property right here, am I going to get negative x squared? 4 times negative 2 gives me negative 8. X times x gives me x squared. Lastly then, 12x divided by 4x, that's positive 3, because 4x times 3 is 12x. And there's the answer that we just got. Okay, good luck on your homework. Thank you for tuning in.